Hello everyone, welcome back to my YouTube channel. Today we are going to see State Board, Class 10, Science 1, Chapter number 7, Lenses. In a previous chapter where we said about the refraction of a light, we had already said about the concept of the refraction of a light. How the light is bending towards normal or away normal when there is a change in a medium. In this particular topic, we are going to talk about the spherical glasses. Spherical glasses are nothing but we call them in a general way or in a general language we call them as lenses. This particular lenses what we have is very useful in our day-to-day life. When we talk about the old age peoples, they require these spectacles. That spectacles contain the different kind of lenses according to the need of the person. Not only that, the watch repairer, if you have observed them, they are using a small lens which they are placing in their eye to see the small particles or the small screws or the parts of the watches. In this particular topic, we are going to talk about the image formation by the different kind of the lenses. Lenses, basically we are going to learn different kind of lenses, what they are, how their structure is, how they are forming the image, and some more related topic with the lenses we are going to see in this particular chapter. So let's begin with the chapter. The first of all, when we talk about the lenses, they are a part of the solid spheres, spherical mirrors. You can see over here the spherical mirror they have shown. If there is a one sphere made up of a glass and part of that we are taking the part of the circumference of that sphere, then that will be nothing but what a curved surface. In this particular section we will see the different kind of the lenses. On the two different faces what they have, we have a different kind of the lenses. Now here if you will observe, the both are the convex, and that's why the name is given as a biconvex. Bi is for two and the convex because it's bulging outside. Then next we have as a plano convex. Then we have a positive meniscus. Then we have biconcave because from both the side it is a concave. Then we have a plano concave. One side is a plane and one side is a concave. And then we have a negative meniscus. So this different kind of the lenses we have, and this particular lenses what we have can be used at different places according to the need and according to the image formation we required. Now the further is some more information they have given about how this particular lenses are made. See, suppose if we have two spheres of a different radius, and when they are crossing each other, they are forming the convex lens, and when they are not crossing each other, they are just placed nearby to each other, and their inner bit part or the inner space what we have is filled with a solid glass, then it will form as a concave. This is only for the understanding. Actual making is a totally different. This is only for understanding purpose. Now here, why this is required, as we know that it is a part of a two different spheres. There are two center of curvatures we have. Two center of curvature, two radius of curvature, because two faces. Let's go back to the previous diagram over here, or the two previous if I'm talking about this particular section, then this is a part of a one sphere. This will have its radius, center of curvature. On the other hand, when I'm talking about this surface, this will be part of another sphere. So for this we will have some different radius of curvature, different center of curvature. So this is what two faces are the part of a two different spheres, and that's why we have a two center of curvature, two radius of curvatures for the lenses. Let's go ahead. Center of curvatures, radius of curvature, these things we are discussing now. So let's go towards that and see the definitions we have for it. Center of curvature, The center of a sphere whose parts form surfaces of the lenses are called center of curvatures of the lenses. A lens with both surfaces spherical has two center of curvature, that is C1 and C2. Same way, when we talk about the radius of curvature, the radii R1 and R2 of the spheres whose parts form surfaces of the lenses are called the radii of curvature of the lens. Next, we have a principal axis, the line passing through this both the center of curvature. Because if I want to draw over here, then if I have a one convex lens and two center of curvatures, one is this side, one is this side. If I am drawing the two center of curvatures, one at this place, one at this place, then the line joining this two, C1 and C2, if I am labeling, then the line joining this two is called as the principal axis. The imaginary line passing through the both center of curvature is called the principal axis of the lens. Now, the next what we have is the optical center. Optical center is nothing but the point inside the lens on the principal axis through which light rays pass without changing their path is called the optical center of the lens. In a simple words, the center of the lens, whether it is a convex lens, biconvex or any lens, the center of that lens will be called as the optical center, and every light ray which is passing through that optical center goes straight without any deviation. Next is a principal focus. Now the concept of this principal focus is what? Whenever light falls on this two spatial category, what we have to discuss under this particular chapter is a convex lens and the concave lens. When light ray falls on it, the parallel light rays which is coming from the infinity, we consider this parallel rays are coming from the infinity on a particular lens, then this particular light rays, the incident light rays, when strike on the lenses, they change their path because there's a change in a medium. So after the refraction through the lens, the light rays, whether they are converging at one particular point or diverging away from each other, it depends on the particular lens. So when we talk about the convex lens, the light rays are converging at one particular point. Here you can see this light rays which are parallel to each other. After reflection, they are converging at one particular point. So that particular point where it's converging is called as the focus. When we talk about the concave lens, the light rays are diverging. They are going away from each other. And that's why we are taking them backward in the direction, and where they are meeting, that particular is called as the focus of the concave lens. So this is nothing but what the concept of the principal focus. When we talk about this convex lens, it is also called as the converging lens. You can see over here it's already mentioned. The type of a lens is called as a converging lens for the convex, and for the concave it is a diverging lens. Or the principal foci of the concave lens, we have two principal foci, f1 and f2. In both the cases we have the same f1 and f2. Now this is nothing but what about the principal focus. Now the method of drawing the ray diagrams. For that we will discuss the convex lens today in this particular section. Principle or the rules which we follow for the ray diagram. Ray diagrams, they are a very important part of the image formation. In that, first of all, what we will discuss, if the light ray or the incident ray is parallel to the principal axis, then after refraction it will pass through the principal focus. And the vice versa. The second rule is just vice versa of it, or the reverse of it, or the invert part of it. is if the light ray, incident light ray is passing through the focus, then the reflected ray will pass through the refracted ray will pass through the parallel to the principal axis. Here all the places they have given is reflected. It is not reflected, it is a refracted ray because the lens, the light is passing through it. So it is a refracted ray. Further is the next one, as already we have discussed while discussing about the optical center. The light ray which is passing through the optical center of the lens goes straight without any deviation. So this particular section we have talked about the image formation by the convex lens. These are the rules we have. Rule number 1, 2 and 3. Already we have discussed. Again I am repeating. The first, if the light ray, incident ray is parallel to the principal axis, the refracted ray will pass through the principal focus. Second rule says that if the light or the incident ray is going through the principal focus, then the refracted ray will pass through the, or it will go parallel to the principal axis. And in the third rule, if the incident ray passing through the optical center, then it will go in a straight line without any deviation. So these are the 3 rules which we have to follow to make each and every ray diagram. So let's see one of the ray diagram over here. That is, if the object is placed between infinity and 2f1. If the object is placed in such a way. So here let's see what exactly we have. The one ray we have to take parallel to the principal axis, and if we are taking parallel to it, it will pass through the focus. And one we will take through the optical center and it will go without any deviation straight. So wherever they are crossing each other, there we will have the image. Now, how to draw this? So to draw this, what you have to do is, first of all, draw the principal axis. I'm just giving you a hint how to draw this ray diagrams. Then you can practice in your notebook after the finish of this particular video. So this ray diagram, we have to start with principal axis, draw the straight line. Then after this, first select the center point of this, and from here draw the or make a mark on both the side at almost 3 centimeter. On both the side you can mark it like this. So after marking it, take this as a center using your compass. Draw the one curvature like this. Then after that, use this particular point and draw the curvature over here. So you will have your convex lens. And after this, label the points. Label the points. This is your 2f1. This is your f1. This is your optical center. This is your f2. And this is your 2f2. Now, dimensions, if you don't remember, you can rewind the video and you can check it out what the dimensions I said. After this, you have to place the object wherever they said. Here I am taking beyond 2f1. So here I will draw the object. Once the object is drawn, don't forget to give the arrowhead to the object and label it. I'm labeling it. This is A and this is B. After this, what we have to do, we have to go towards the further ray diagrams now. First of all, I'm going to take parallel to the principal axis. The ray we have to show on it, the ray head. Then after reaching up to this particular point, from here this will pass through the focus. Okay, this will pass through the focus. Again, show the arrowhead over here, and the one ray I will take which will pass through the optical center, and then wherever it's crossing each other, wherever it's crossing, there we have to draw our image, and this will be A prime, B prime. This will be A prime and B prime. And one thing I have missed over here, that the arrowhead I have to give over here. Arrow marks are very important in the ray diagram. If you are not drawing it, you will lose your mark. So this is a way by which you can construct or you can draw the ray diagrams. So this ray diagram you have to draw in your notebook, and you have to post me back in the classroom app by today evening 7 o'clock. Once when you are watching this video, immediately within 1 hour, draw this ray diagram and send back to me. Or you can post that in a comment section also. If you have drawn, or in the Google Classroom app, post this in the classroom. So this is the activity you have for the ray diagram. Okay, so this is how the ray diagrams are made. This is about the ray diagram, one of the ray diagram. Now after that we have the table of it. 1, 2, 3, 4, 5, 6 different positions they have given, and how the image is getting formed. Now here they have talked about the nature of the image, that is real and inverted, real and inverted, real inverted, real inverted, real inverted, and then last one is a virtual and erect. What this virtual and erect, this all we will discuss in the next video. And this another type of a lens, that is a concave lens, this all we will discuss in our next video. So till that time, keep practicing this particular ray diagrams, the one which I already had explained, that one, and after that this 6 diagrams, make that and practice it.